Hello, guys. My name is Desmond, and I welcome you to my lesson for today, where we'll be looking at your mathematics paper 1. So, good people, just in case if you missed today's lesson, just be aware that it will be recorded and posted on our social media platforms. It could be available on my website, YouTube, or any other social media platform. So, ladies and gentlemen, without any waste of time, as you can see over there, in today's lesson, I want us to be talking about all that you're seeing over there. Number 1 being number patterns. I want us to discuss number patterns, sequences, series, and most importantly, ladies and gentlemen, they will be explained in this order. The first one will be looking at number patterns, sequences, and discuss all under sequences, and have a look at series and discuss all under series. So let's now try to talk a little bit more about number patterns. So guys, there's load shedding on my side, so just in case if for some reason I'm disconnected, just to be aware that I will be back after, or let's say in less than a minute. Okay, so ladies and gentlemen, all that I'll be talking about from now on, it has to do with what we call number patterns. So remember, guys, in almost all of my lessons, it's not really necessary for you to be writing every time when I write something. But most importantly, just make sure that you listen very carefully. And again, in case if you've got any questions, you can just in the middle of my explanation or whatever, ask that question. And again, in case if you need the notes that I normally use to prepare for my lessons, you are welcome to drop me an inbox, and then from there I will share the notes. Okay, number patterns. So guys, it is very much important that at all times we work towards simplifying every mathematical term. So in this case, what we're looking at is number pattern. How do I explain to a primary kid? How do I explain Bonolo to a grade 7 learner what is number patterns? In short, it's just a list of numbers in order, full stop. That's it. So that is how, in short, we define number patterns. So I'll just quickly write it down over there to say it's just a list of numbers. So we talk about list of numbers in order. Full stop. Easy, 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 easy. You will never, never, ever forget the definition of number patterns when it is simplified in that manner. Okay, so very much important, guys. We need at least 3 numbers in the list to work out if the numbers form a pattern. Very, very much important there, ladies and gentlemen. So the word at least, it means you need from that number going up. So what I'm saying is we need at least 3 numbers in that list of numbers to tell, ladies and gentlemen, if those 3 numbers or more form a pattern. Very, very much important, ladies and gentlemen, over there. So that means with just 2 or 1 number, we cannot work out if the numbers form a pattern. I'll give an example. Shravan, let's say for example, e.g., you are given 2 and 4, then da 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 da. So can you see, based on what I said, ladies and gentlemen, if you are given 2 numbers, it is not easy to tell if this forms a pattern. And also, I'm going to explain why I'm saying it is difficult to tell if these two numbers form a pattern. So the reason to that is easy, guys. Different patterns are possible when you just have two numbers. It could be 2, 4, 6, 80, 8, 10, whatever. And again, it can still be, what is it? It can still be 2, 4, 8, 16, or whatever over there. So it doesn't end there, ladies and gentlemen. I can still go to the third example where I'm saying it could still be 2, 4, and repeat itself again. 2, 4, 2, 4, and so on and so on and so on. So that is the reason why I am saying with just two numbers, we cannot be sure what the pattern is based on these possible examples. So that is why I'm saying, ladies and gentlemen, we need at least 3 lists to work out if the number forms a pattern. Very, very much important, ladies and gentlemen, over there. So determination, I hope you still remember very well that in the beginning of this year, we did discuss to say a single number in a sequence or in a pattern is called a term. So this is a single number. This is a single number. What does it mean? It means in a pattern, numbers or terms are separated by that sign. I think it's semicolon. So that means this is a term, 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 and we have more terms. So let's see. 1, 2, 3, 4, 5. So that means we've got 6 terms that we can see over there. So now, very, very much important, ladies and gentlemen. So that means term 1, it is going to be called T1. So this is term 1, and this is going to be term 2. This is going to be term 3, and so on, good people. So there's something special about term 1. So term 1, it is given a letter being A. So that means if you like, you can call the first term in the sequence or in the number pattern T1, or otherwise, if you had a very nice breakfast on that day, you can call it A. But it doesn't necessarily mean that only when you have a good breakfast you call it A. Even if, ladies and gentlemen, you don't have a breakfast at all, you can still call it A or term 1. Very, very much important over there. But when it comes to term 2, 3, 4, 5, 6, and whatever, we call it as term 2, term 3, whatever the term may be in the number pattern. So in short, that would mean if we want to talk about term number 30, we don't have to write 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4 until we get to term number 30. We don't need to do that. So in short, we can still say a term 30. We can still say term 50. We can still say term 105. But we don't need to then write everything up to term number 105. Very, very much important over. So that means we can go on and on and on and on up to 10 million, ladies and gentlemen. So because examiner may choose any number or any term, we therefore generalize to say up to whatever nth term. So you can just say, actually, it is endless when it comes to terms on a number pattern. So this n, it is waiting for examiner to tell us which nth term is he or she talking about. So remember, guys, everything that I'm doing now is just to tell you guys a story of which you don't need to grab everything in one lesson. You just need to be aware of what I'm talking about. I'm telling you, when we solve for exam type of question papers, that's when everything is going to make a perfect um sense. I almost said a perfect wedding. I know someone um almost said a perfect wedding there. No, Olani, she likes that channel on Mojala. Anyway, um, ladies and gentlemen, this lesson is going to be posted on my YouTube channel. So just in case if you missed something, you can still catch it up online. But attending lessons, it helps, because in case if there's something that you don't understand, you can instantly ask me a question on that. So good people, this is all that I wanted to make you aware of as far as number pattern is concerned. So this is what I've talked about. I'll just make a tick over there so that we can track our progress on this list. So ladies and gentlemen, all that I'm giving to you is all that I used in order to pass my mathematics very well. So I believe it is going to benefit you guys in your exams. So just make sure that you do not miss any of my live lessons, because an advantage is that you can engage and ask questions and whatever. And for those of you who are on other packages, you can still request for us to redo this lesson. Okay, so before I move to number 2 being sequences over there, is there someone, ladies and gentlemen, who's got a question based on all that I've explained over there, or was it clear? Bonol, Shravan, let me see who's also on the line. We've got the greatest determination, Toli, gets grace, lo nompumelelo mtiani. Are we good that side? Is everything okay? So remember, guys, in case if you want to comment, there should be a button somewhere there where you can click to unmute and speak, and then once done, make sure to mute. So guys, do we move on? Is everything clear on your side? Are you happy there?
Yes, everything is clear.
Someone made an indication to say all is good. Toli, are we doing okay that side? Let me see. Grace? Okay, 100%. So I assume all is good on your side. So what I'm going to do, guys, is just to remove or erase all of these and move to the next part of our lesson for today, which is sequences. So all that I'll be talking about, it has to do with number 2 being sequences. So ladies and gentlemen, it is very, very much important that when you study, you have a look at the table of contents for whatever textbook that you're using. Because can you see how nicely this information is arranged? You therefore know very well that you've got what we call number patterns, which is all that I've spoken about. And then you've got sequences. Under sequences, you've got types of sequences: arithmetic, quadratic, and geometric, which is what I'm going to be talking about. So this is where, ladies and gentlemen, you need to pay full attention. Hey, before I forget, ladies and gentlemen, please, please do allow me to say it is very much important that I say it is very, very much important, good people, because what I'm about to say, Mr. Shravan, it is very, very much a day without learning something new. It's a day wasted. By so saying, good people, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Massively important over there, ladies and gentlemen. Okay, sequences. What type of sequences do we have or do we know about? As I've said, we've got arithmetic, we've got quadratic, and we've got geometric. So now let me talk about the first one, being arithmetic. So, good people, the moment you see the word sequences, think about arithmetic, quadratic, and geometric. So, what can we say with regards to arithmetic sequence? There's nothing much to talk about there, ladies and gentlemen, other than us saying this is a sequence where the common difference between consecutive terms is constant. Guys, I've spoken a big English over there. So let me just repeat it for the last time so that we are all on the same page. What I'm saying is an arithmetic sequence. It's a type of a sequence where the common difference between consecutive terms is constant. Easy, 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 easy. I may be saying it's easy because I understand it better. But one thing for sure, as we go deep with our lessons, that's when it's going to make perfect sense. But for now, you just need to be aware that that's where we have a common difference. Can someone in the meantime think of an arithmetic sequence so that I can make use of it to explain what I'm saying over there? Is there someone who can think of an arithmetic sequence? You just give me the three terms. So what I'm saying is a sequence where a common difference is common between let's say a consecutive terms is constant. What am I saying there, guys? I'm saying an arithmetic sequence is a type of a sequence where we've got common difference, where the common difference is constant between consecutive terms. Yes, I can therefore remove all of that. So it doesn't really matter that much in terms of how you give the definition to that, but what matters the most is that we've got common difference between consecutive terms. Okay, so I had someone wanted to give us an example of an arithmetic sequence. What is it, honorable member? What are we having there? Let me see. Who
Example
was
of
it?
arithmetic
Mm-hmm.
sequence 2, 4, 6, and 8.
Easy, 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 easy. Thanks very much, Likeleli. So, for those of you who remember from the beginning of our lesson, I did say we need at least 1, 2, 3 terms to tell if the number pattern forms a pattern, or otherwise if the list of numbers forms a pattern. So let's see the weight difference. It means you must be minusing one number from another number. That is what the weight difference refers to in mathematics. We know the product is multiplication when you multiply two numbers or two terms, and then the sum, that's when you add the values, and then I think it's a quotient when you say a number divided by another. Okay, common. What does the word common refer to? So in other words, or in simple English, it simply refers to numbers being the same. So it's more like we're talking about the same difference, or whatever difference that you get, it has to be the same between consecutive terms, and those difference needs to be common. Okay, let's try to check. This is where we therefore have term 2 minus term 1. What are we having there, ladies and gentlemen? We obviously have 2. So it's more like we're saying 4 minus 2, it gives us 2. What are we having again? We have 6 minus 4, which gives us 2. So can you see? We are now having a what we call common difference, of which I used to call it CD. Why am I saying this is CD? So I just took that first letter and that first letter to call it common difference, and I refer to it as CD. Most importantly, guys, I knew very well that it might be necessary to just add a spice there to say this is actually the first common difference. So why am I saying is the first common difference? Is because when I subtract term 2 and term 1, already I'm getting 2. That term on the same or on the original given sequence, you say term 3 minus term 2, it gives you 2. So can you see? This is the first line of difference which are common. So this number pattern or this sequence, it qualifies to be arithmetic sequence. Very, very much important, ladies. So the reason why I said we just need at least 1, 2, 3 terms in a number pattern to determine whether it forms a pattern is because we needed two values of the difference over there to tell if they are constant or not. Therefore, we know very well that if we want to get, for example, to 10 number 50, we just add by that difference. We add by 2, we just keep on adding. So can you see, guys, it's more like in that direction. Where do I write this? So it's more like in this direction you subtract. What am I saying there? I'm saying if you say this, you go in reverse. So you subtract a that. And then again, you say this, you subtract that, it gives you that. But if you now want to therefore get these values, you therefore go in that direction with an opposite sign being a plus. So that means you just say this plus that, it gives you that, plus that, it gives you that, plus that, it gives you that, plus that, it gives you plus. Imagine, ladies and gentlemen, imagine if they wanted to punish you because you did not wash the dishes, and they say determination, we are now punishing you because you did not write your homework. This is what you must do. You just need to add every term by the common difference until you get to term number 5,550. Imagine how long it is going to take you to get to 5,550. I know we've been waiting for Jesus to come back from heaven, guys, but I'm telling you, by the time when you get to 5,550, we'll be chilling here with Jesus doing some nice lessons over. Okay, someone lazy did this. They said, I can't keep on adding to 5,000. No, it's going to take long. I would rather spend much of my time thinking about this nicely. And guess what? That lazy friend of mine, ladies and gentlemen, he actually came up with a very nice thing. Um, Let me just quickly check. I see Grace has got their mics unmuted. Grace, just make sure that always you keep your mic muted so that we don't get disturbed by the background. Okay, so a friend of mine, guys, they came up with this out of their laziness. This is what came out of the laziness of my friend who was punished but lazy to count until 5,550 times. Imagine how long it is going to take you to get to that. It's going to take forever. But this thing is very powerful, ladies and gentlemen, because it can take you anywhere. You can get to whatever number that you can think of, even the numbers that you've never heard of before. This formula can take you to that particular term. So it's even easy to analyze this formula. Remember, I said A, it's actually term 1. So if you had a nice breakfast determination, you call your first term in the sequence term 1. But otherwise, in case if you had your breakfast was just a boiled egg and a peanut butter, um, I'm sure someone is just going to refer to their term 1 as um, A over there. So N, easy, 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 easy. N is just the number, guys. N is just a number. N is just a number. It's as easy as that. So, uh, let's see. What else can we talk about on that formula? Maybe D. So, this D, ladies and gentlemen, is that first C D. So, this is D for the difference. Which difference? The difference you get when you say term 2 minus term 1. When you say term 3 minus term 4. When you say term whatever minus the previous term. If you have a common difference, then you can with confidence substitute it over there. So, ladies and gentlemen, this is all that I wanted to talk about with regards to arithmetic sequence. I'm just not sure if there's someone who's got a question before we move to the next type of the sequence. Guys, any questions or are we doing good that side? Is everything clear for everyone? Let me see who's on the line. Grace, I'm now going to unmute you, but just make sure to have your mic muted. Bonolo, I think you are attending the lesson for the first time, you and Nompumelelo. Nompumelelo, how is it going that side? Can you clearly hear me and can you clearly see over there? Bonolo. Kogza the Kogza. Kuhamba njani lapho? Kuhamba njani? So, Nompumelelo and Bonolo, remember, if you want to speak, click on the button there which says unmute. Then that's when you'll be able to speak. Because you might find that you're speaking that side, but I'm not able to hear you. Determination, are we okay that side? Shravan, how is it going there? Likeleli Tole.
Yes.
Okay, 100%. So, just in case if Tole, you wanted to say something, or are you okay that side?
I was just responding to say yes, I understand.
Okay, 100%. So remember, guys, in case if there is no any question, it serves as an indication to me that we are all on the same page. But just in case, if maybe I'm breaking or whatever, just bring it to my attention so that I can do the necessary updates or reconnect my internet. So now I'm going to remove all of this. So remember, guys, in case if you just joined now, just make sure that you just move with the flow. This lesson is going to be posted as soon as I'm done, and then you can catch up and make sure that you familiarize yourself with whatever that we've discussed in the beginning of this lesson. Okay, number 2, what I want to talk about is what you guys know very well as a quadratic. Someone remember to mute your mic. A quadratic sequence. So I've spoken all about an arithmetic sequence. I've always regarded these two types of sequences as, the ladies' weaves. This one, it's more like it's 8-inch, and this one, I'm not sure if we have 16-inch or 17-inch. But to me, quadratic sequence is just an extension of an arithmetic sequence. That is why even in my order there, I started with arithmetic, then followed by a quadratic. So let's now talk a little bit more about a quadratic sequence. So remember, I said with my mouth wide open, in arithmetic sequence, we need at least 3 numbers to determine if the numbers form a pattern, of which we can tell if the type of a pattern is an arithmetic or not. Back to what I've said, quadratic sequence is just an extension of an arithmetic sequence. So in this case, good people, we need at least 4 numbers to tell if a sequence forms a quadratic sequence. Massively important, ladies and gentlemen, over there. So in short, at least 4 numbers are needed to determine whether the sequence is a quadratic or not. Full stop. I will say it for the last time. So just make sure that you listen to me very carefully over there, honorable members. At least 4 numbers are needed, good people, to determine whether the sequence is a quadratic or not. So that means you cannot tell if the sequence is a quadratic if you just have 1 number. You cannot tell if you have 2 numbers. You cannot tell if you have 3 numbers. But the moment you start having 4 numbers, that's when you can tell if it forms a quadratic sequence or not. If it doesn't form a quadratic sequence, then it could possibly form an arithmetic or geometric or whatever or something else. So can you see? We have already spoken about what I mean about extension of that. So let's regard arithmetic as 8-inch and quadratic as 16-inch. Okay, let's now talk about this example, ladies and gentlemen. Let's say for example, we've got a 6, we've got 12, we've got a 22, we can still have 36 over there. 1, 2, 3, 4. So can you see? I said we just need at least 4. So the word, ladies and gentlemen, at least 4, it simply means starting from 4 and more. So that is what at least means. Very, very much important, ladies and gentlemen, over there. Okay, remember, with arithmetic, we just determined the first common difference, of which I said I call it the first CD. So let's see what happens when you determine the first difference over there. So we say this is the first difference, ladies and gentlemen, and we check how it looks like. So can you see when you say what is it, 12 minus 6, it gives you 6. When you say 22 minus 12, it gives you 10. When you say that minus that, it gives you 14. Very, very much important, ladies and gentlemen, over there. So can you see we are not having a common first difference? That is why I'm not regarding this as first common difference, because it is not common. The numbers are not the same, or the difference are not the same. So let's test the second difference, and let's see what are we having over there. So it's 10 minus that. What are you getting there? I think it gives you 4. Then no, don't punch a calculator. I'm having a feeling someone is trying to punch 10 minus 4. No. It's easy. Let's see. 14 minus 10. Don't punch, honorable member. Easy. It's 4. Okay, so let's now analyze this. Can you see? We are now having a common value over there. What does it mean? It means we now have the second common difference. So can you see? If it's an arithmetic, I'm going to call it first common difference. But because the first difference is not common, then I regard this as first difference. But the second common difference, the second difference is the one which is common. It is therefore a second CD. So can you see, ladies and gentlemen, the reason why you needed at least 4 values or 4 numbers to determine whether a quadratic sequence, if this forms a quadratic sequence or not, is because you needed 2 terms to compare those terms. By comparing, I mean you wanted to check if this is the same as that. Because it's the same, then it means this is a quadratic sequence. If it wasn't the same, then it could possibly be a geometric, because it failed to be an arithmetic. So that means the first step, it actually helps us to determine if it qualifies to be arithmetic. Then we notice it doesn't. We try again. We can see common second difference over there, or second common difference. Then it qualifies already to be a quadratic. Then we don't worry to test if it's geometric. But if it failed also, then we test if it's geometric. It has to be one of those. Very, very much important, ladies and gentlemen, over there. So a pattern with a common second difference, ladies and gentlemen, we call it a quadratic number sequence. It is as easy as that. Guess what? Our lazy friend, this lazy friend of mine, he made our life easy, because in examiner will just expect you to use this general formula. They won't say count up to 150 term or whatever. Sometimes being lazy, it helps, guys, but just make sure that you don't say this in front of your parents, because they are going to make sure that they punish you until you understand that being lazy, it doesn't help. So, but a friend of mine, ladies and gentlemen, he came up with this out of laziness of trying to do the zigzaga until you just come back. He noticed that he can't manage, so he ended up coming with this. What is this, ladies and gentlemen? You remember, he generalized that to be nth term. So that is nth term. So that means up to whatever term that you want me to get to. I'm telling you, once you have this formula, you can get to whatever term that examiner may want you to get to. So A, again, ladies and gentlemen, you can refer to that as something else, of which I'm going to then explain as we go deeper. We also have n over there, which refers to a number, ladies and gentlemen. So we also have other letters there, B and C, but don't stress that much about those. Mr. Shravan, you remember on our very first lesson, we did discuss to say when you are given something similar to this, because of that power, it qualifies this to be a quadratic. So remember, because in this case we are dealing with a chapter of sequences, then we regard this as a quadratic number sequence. So this is the general formula. But if we were talking about equations, then because of this power, then it was going to qualify to be a quadratic equation. So that means this a squared over there, whatever letter to the power of 2, it makes it a quadratic. It's just a matter of you asking yourself, what type of a quadratic is it? Is it a quadratic sequence? Is it a quadratic equation? Is it a quadratic inequality? Is it a quadratic whatever, ladies and gentlemen? So, okay, let's see. Where are we? Something very, very much important, ladies and gentlemen, of which I want you guys to be aware of. I am forced to now remove all of that information over there. So let me just rewrite that formula somewhere up there and explain what I want you guys to be aware of. Okay, this is the general formula. Tn is equals to an squared plus bn plus c. So what is this thing, guys? This is what we call the general formula. Okay, so this is the general formula of a quadratic sequence. Very, very much important, ladies and gentlemen, over there. Okay, we obviously have term number 1 on every sequence, whether it's arithmetic, it's quadratic, or it's geometric. There's always something special about quadratic, ladies and gentlemen. Even when we solve for x, there is always something special about a quadratic, whatever the case may be. In this case, it's a quadratic sequence. So term 1, it's not just term 1, but it also has a formula. Just correct me if I'm wrong here, but the formula for term 1, it's actually equals to a plus b plus c. And again, you remember, guys, I said in a quadratic sequence we have what we call the first D and not the first CD, but the first D. Okay, so the first D also has got a formula being 3A plus B. Very, very much important, ladies and gentlemen, over there. Okay, you do know very well that we still have the second CD. It also has a formula, ladies and gentlemen, and that is equals to 2A. Very, very much important, ladies and gentlemen, over there. So it's more like on that sequence that I've given you as an example. The rest doesn't matter, guys. For as long as you've got your A value or your term 1, and again, for as long as you've got your first difference, and again, for as long as you've got your second common difference, guys, I'm telling you, Oboza, yeah. Why am I saying that? Is because all that I removed you do not need in order for you to determine the nth term. So, in short, ladies and gentlemen, the reason why we are having these formulas is because on the general formula, we don't want to be having a number being represented by letter A. We can just make use of all that information to determine the A value and again determine the B value and again determine the C value. So the main purpose of us understanding that the first term can be equated to this, first difference can be equated to that, second common difference can be equated to that. The main reason to that is because we simply want to determine the A value, B value, and C value, and that's all, ladies and gentlemen. So it's more like us going to a war. We make sure that we've got we've got the guns, we've got some food, what else do we need? We've got some machinery, ladies and gentlemen, so that we are ready to fight other soldiers in a war. Who's the other soldier? It's examiner, as he will be asking us some questions that we need to answer. Easy, 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 easy there, ladies and gentlemen. Someone might be asking themselves to say, but say, it is not at all the times where we are given 4 terms. Sometimes they can just give 3 terms and still we use this information for quadratic. Okay, in answering that question, Koli, it is because the moment examiner gives you 2 or 3 terms and you end up using this, it's because somewhere in the statement they must mention to say, given a quadratic sequence with probably the following terms, and they just give you 2 terms. Can you see? You just need to apply all that you know regarding a quadratic sequence. You don't need to test whether it is arithmetic, quadratic, or geometric. So in my case, I've always suspected and ended up confirming that the moment they start giving you 4 terms in a sequence already, you just smell a quadratic sequence, because if they wanted you to deal with an arithmetic or geometric, they were just going to give you 3 terms in a sequence. But the moment they give you 4, you straight away try to test if it is a quadratic. But otherwise, if it's 3 and they did not mention, then you start by checking the first common difference. If you don't get it, then you try and check for a geometric, unless if they state to say given an arithmetic, given a quadratic, given a geometric, then you know very well what to do. Good people, remember, everything that I'm saying now is just a story for you guys. Everything is going to make a perfect sense when we solve exam type of question papers. I'm telling you guys, you won't want to miss that. Okay, anyone who's got a question before we move to the next part of our lesson for today, which is geometric. Let me just make a tick over there to say this is what I'm discussing, and I've gone through arithmetic, and you guys said you are happy that side, and I've just discussed a geometric. A quadratic. Before I move to geometric, is there someone who's got a question over there? Or Koli, unembuzo lapho, or yonke into ephashasha. Mr. Shravan,
Sir,
Ospraise,
you
can
can
be
right, sir, understand.
yonke into right. Bonolo, can you click on unmute? Umputshor o right ka for.
I'm fine, sir.
In which province are you, Bonolo?
Gauteng.
Mo Gauteng, wena o makhi mos. So everything was swara name.
Yes.
Okay, Maki, Shravan, how is it going that side? Are you okay? Are you good that side?
Yes, I'm understanding.
Yes, sir.
100%. Grace, how is it going there, honorable member? I'm suspecting Grace is watching Gomorrah. I'm telling you guys, Grace, I know very well that she's watching Gomorrah. That's why she's not able to tell if all is good. Okay, likheleli Ngwebele, sihamba njani lapho? Likheleli,
Sir.
likhe. No. I see Grace. What's happening there in Gomorrah? Is Ntati
I'm
still
not
in cars
watching
there?
Gomorrah.
Near. I know you're watching Gomorrah there. And you muted the TV so that I can hear. Okay. Likheleli. Hey, Likheleli ran away. Cogs are the
Probably watching
cogs.
Gomorrah.
This one, Likheleli, I know. Let's test this one. This one is in KZN. Cogs are the cogs.
Yeah, sir. So far, so good.
So far so good in Ndlovusa. Okay. Nompumelelo Mthiyane. Hello.
Yeah, everything is good, sir.
100%.
Sure.
Okay. So guys, in that case, you've just given me a permission to move to the next part of our lesson, being a geometric sequence. So this chapter, ladies and gentlemen, it is not that much complicated. I'm telling you guys, all that I'm saying now, it's all that I needed to know in order to obtain full marks on this chapter. You just need to be aware of all that I'm saying. Why would you still fail if you know all that I say is all that you need to know? Likheleli is because something that they might not be teaching you in class at school is how examiner ask questions, which is the most important thing. You can be good in any possible way in terms of knowing your notes. You can be 100% in knowing all of your notes, such that even if you get to exam class, you can just rewrite all of your notes. But if you do not understand how examiner ask questions, you will be in trouble. I'm telling you. You might know that this is 2. You might know that this is x. You might know that 4 minus 2 is equals to 2. But I'm telling you, you might not understand how examiner wants you to give that answer as 2 from 4 minus 2. For example, they can say, what is the difference between 4 and 2? If you do not know or understand the word difference, you are in a big trouble. What is the product of 3 and 5? Can you see? You know very well that 3 times 5 is equals to 15. But the moment examiner says, what is the product of 3 and 5? That's where it starts confusing. So that's what I mean by saying you might know that 3 times 5 is equals to 15. But examiner says, what is the product of 3 and 5? So it's more like what I'm telling you guys is that 3 times this is equals to 15. So on our next lesson, I'm going to be teaching you guys on how examiner ask questions, how examiner can be tricky. How do you notice if you are making a mistake? How do you prove if your answer is correct? And so forth and so on and so forth and so whatever. Very, very much important, ladies. So This is just an introduction to this chapter. Solving exam papers is what we do, ladies and gentlemen. We do more of solving exam question papers. So in my case, guys, when I was in matric, I did not spend much of my time studying textbook, reading more of my notes and whatever. I just had a textbook that I would read once, 2 times, or 3 times a day. The next day, I just do summarized notes. From there, I just put that textbook away. Then I focus on my notes until I understand them better and how to apply my notes. Then from there, I invest much of my time into solving exam question papers, because that's where you learn some more through questions asked by examiner. Then you consult with your teacher to say, hey, this guy is saying, what is the sum of this and this? What are they saying there? Because I've never seen that in a textbook. It's not there on my notes. Then they say, let's see your notes. Okay, so you see here you're saying this plus this is equals to whatever. So examiners actually in a smart way asking you what is the answer that you get when you add this and that. Then you're like, oh, now I see. Then you do more and more and more question papers. You do question papers for 2015. In my case, I started from 2009, 10, 11, and 12. 13, I wrote my matric. Guess what? I murdered it, guys. Hey, I murdered it. Hey, Likeleli. Hey, I murdered it. And guess what? I still have the notes that I was using and also the tactics that I was using to cram some of the stuff. Some of you guys know this song, Hydrogen, Helibi, Bokan of Namaka, Alsip Satlorago, Kasactive Chrome. Emon, Fekuneguzing, Kake Asibram. Hey guys, what I've just saying right now is it's a periodic table from hydrogen up until the last atom. It's a very nice song. I just need to release it and add amapiano nyana there. And I'm telling you guys, it will be song of the year. But guess what? When I did my first year, it helped me a lot because there was a question paper where you needed to know the mass of a certain item element. Then I remembered, man, I've got a song, hydrogen, hey, guys, that test during my first year, Bonolo, I moored it also. So it's all about mooring. But how do you moor if you don't know this information? Okay, what information am I talking about? Good people, when there is a common ratio between consecutive terms, with confidence, we can therefore say this is a geometric sequence. Okay, so that means when we are dealing with a geometric sequence, that's when we've got a common ratio. Guys, very much important. What does the word ratio mean? Ratio means something over something. That is a ratio. Something divided by something. That is a ratio, ladies and gentlemen. When you get 3 out of 100, this is a, hey guys, the reason why I'm saying 3, it's embarrassing, but I'm going to tell you guys. When I was doing my first year at UJ, you wouldn't believe, on my very first test I got 3%. From distinctions in high school to 3%. Hey guys, I thought of going back to Limpopo on that day when I got, actually not even when I got married. I could feel it because I was sweating in that test. It was difficult, ladies and difficult. I was sweating. And I thought maybe I would get above 15 yana there, above 16 yana there. But cogs are the cogs. 3. This is 3 cogs. 3% out of 100. So it was a bit of a challenge, but I remembered that no matter how slow you are, there's always a strategy, guys. There's always a strategy to improve on your weaknesses. And in this case, in mathematics, physical sciences, life sciences, and geography, you just need to read the same thing over and over and over and over and over and over again until it sticks to your mind. I'm telling you guys, um, during our time, it was a bit difficult to study in English and also speak that English. So we did English in Spain in my case. Actually, we did everything in home language. But you realize that as you do something over and over and over and over, you get used to it such that you don't even struggle to do. Same thing applies with mathematics, physical sciences, life sciences, and geography. You just need to do the same thing over and over and over and over again. I'm telling you, you will never forget. Just imagine, it's 2022 now. I've crammed a periodic table when I was in grade 10. So that was in 2013, 12, 2011. That's when I crammed periodic table. Even now, if you can just draw for me those boxes, I'm telling you, hydrogen, LB, book kind of Ninamagal, Alcil, Sadlorago, Casective. Hey, someone needs to just add up some beats over there, then we produce um, a Mapiano song there. Okay, so guys, I've said common ratio between consecutive terms. We can therefore say we are dealing with a geometric sequence. Common, the word common, don't get confused over there, guys. We're just simply referring to something being the same. Common, same. Common, same. Okay, so our lazy friend. I like this friend of mine, ladies and gentlemen, because he was lazy. He ended up coming up with this thing which looks like this: Tn being equals to ar to the exponent n minus 1. Can you see how small, straightforward and short this thing is? What is this? This is a formula, ladies and gentlemen. This is a formula for determining the nth term of a geometric sequence. Someone in the meantime, please think of an example of a geometric sequence. I'm going to give you an opportunity to just give it to us so that we can discuss based on that example. I pray that you don't give something complicated, because it's going to be a bit tricky to explain. Okay, similarly with the previous types of sequences, ladies and gentlemen, the first term being T1. I told you guys, someone may still refer to term 1 as A. Nothing wrong with that. It's one and the same thing. So we also have the first term in geometric sequence. So in conclusion, we can conclude to say in every sequence, there's always term 1, which means there's always a value. Very, very much important, ladies and gentlemen, over there. Okay, so there on arithmetic, we had the first common difference, of which I regard to that as the first CD. And then now when it comes to quadratic sequence, we had the first difference and the second common difference. And because a quadratic sequence, it's a special type of a sequence, it had multiple formulas there together with a general formula. And most importantly, we need more information to determine whether a number pattern forms a quadratic sequence or not. Massively must. So you remember, guys, I've spoken about the ratio. So that R, it simply refers to the ratio being R. So how do we determine the ratio? So the ratio is the second term divided by the previous term. And it should be the same as term 3 divided by term 2. Why? Because it is a common ratio. So it means in this case, it is the CR. And then for this 2, it is CD. So just to show that you come out of good hands, you can therefore add a spice over there. I know this is a very nice cup of coffee, but let's just add a spice to it. I know it is going to taste very nice. Just hammer a nice raja there and drink it. I'm telling you, we are having the first common ratio, the first common difference, the second common difference. Very, very much important, ladies and gentlemen over there. Okay, so that means even when you say term 4 divided by term 3, you should still get the same ratio, the same answer. Our lazy friend, guess what? He noticed something. He noticed that it seems like when it's 2 there, you just minus 1 and then you get that. When it's 3 there, can you see? You divide by term, you just minus 1 over there. Let's see here. What are we having? So it's 4, term 4 man. Oh, so that means it's actually Tn. So this n, it represents that number there. Over. So it's more like you're just saying that Tn minus 1. So this is the generalization of the common ratio. So it's more like whatever term number, you just divide by that same term number minus 1. So 3 minus 1 is 2. So term 2 divided. So for those of you guys who were confused by this, I hope it did make sense over there. So don't get confused by such information. Just understand the theory behind it. It's because of our lazy friend. One day I'm going to tell you the name of that lazy friend of mine. So this is the general formula for a geometric sequence. I'm not sure, ladies and gentlemen, if all of you that side are doing good, but me, I'm doing good this side. Zote, zochimbra, zobudi. For someone who's in Venda will tell you that I'm saying all is good. It is very, very good. Okay, let's see. This is all that I've spoken about. I'm not sure if you guys can allow me to continue and quickly finish up the last part. I notice we are running out of time over there. But guys, all I'm saying, does it make sense? Are you getting value there out of what I'm saying over there? I see we have Mongale joining, the boy doing them things. Okay, before I propose to move to the next part of our lesson, I remember I asked someone to just prepare a very quick example. What is that question? So, that example, just unmute your mic, mention your name. I'll choose from your names, and then from there, you will give us an example. Because one thing for sure, it's not just one person who thought of an example. Who has an example for us, ladies and gentlemen? Remember to unmute your mic in case if you want to give us an example of a a geometric sequence. Goli, do you want to give us an example?
Yeah. Yes, sir.
Okay, go for it.
It's 3, 6, 24. 3, 6, 12, 24.
3, 6, 12. Hey, Goli,
Yes, sir.
say R.
You say.
Is it too much? How much do you need? How much do you want me to pay you to say? Is it that difficult?
I say it's kind of difficult. So
Only just give it a try, man. Just give it a try, man. Hmm?
I say next time, not today.
Or you still want to practice? Okay, so ladies and gentlemen, we've got an example over there, being the 6, 12, and 24. Okay, so let's see. If I was given this thing, I was going to first say this minus that, this minus that, this minus that. It doesn't give me a common difference. Then I continue and say this minus that, that minus that. Then it doesn't give me the second common difference. Then it means it must be a geometric sequence. So that I'm going to say this divided by that. What am I having there? I think it gives me a 2. Okay, this divided by that, it also gives me a 2. This divided by that, it also gives me a 2. So can you see, after saying term 2 divided by term 1, I'm getting the same number as term 3 divided by term 2. Still the same thing when I say term 4 divided by term 3 over there. So can you see, this thing, it actually follows that generalization where we say t n over tn minus 1 over. Therefore, it means we can use this formula to answer all the questions. So it's more like, in short, what I'm saying, ladies and gentlemen, you need to understand the type of a problem that you are dealing with. Therefore, I always say you stand a good chance of providing solutions to follow up questions based on whatever that you'll be dealing with. And most importantly, guys, this is that term 1 of which it is well known as A, and then now this is what we call CR. What is CR? CR is the common, Oli was going to say, is the common ratio. Okay, so guys, are we happy that side? Do you allow me to now move on to the last part, or what do we do? Mongale, the boy doing them things. Are you good at that side, guys? Are we all happy? Can I just get an indication from just a few of you guys? Are we happy there? Hey, did everyone run away? Am I alone here? Let me check. Like. Okay, Bonox, how are we doing that side? How are we doing that side? Grace, Elo, Nomtian, Nompumelel, Shravan, Ragunen. How is it going that side? Ndlovu.
It's fine.
Everything is good, sir. That's good.
Okay, I know, Kole, you were the last to give. So, guys, this is me trying to check if none of you are watching Generations that side. I know whoever who does not give a response, they are probably watching Mazwi there. Okay, so quickly, we are now about to wrap up, ladies and gentlemen. So we are now on the last part of our lesson. So I so wish to complete this lesson so that whoever will be watching this lesson to catch up, they will be able to get a full package in one lesson, even though it doesn't end here, but we'll just cover all that it is necessary for you to be aware of, especially those of you in grade 10, 11, and 12. So this is just a master class. So a master class, that's where I cover chapters common in all the grades. Okay. Massively. Hey, massively important, ladies and gentlemen, that you pay full attention to every detail. Okay, so now what we'll be talking about is series. We have spoken about number patterns, sequences. We are now on series. As you can see over there, under series, we've got arithmetic, we've got geometric. So that means we possibly have two types of series, being arithmetic and geometric. So you also need to be able to differentiate what is a number pattern, what is a sequence, what is a series. So that's what I want you guys to learn out of this. Okay, something very much important that I think is worth mentioning, guys. It's not at all times where you need to take 3 weeks or 2 weeks or a week or whatever to complete a chapter. Can you see, in just this one lesson, we are able to complete all that you guys might be taking to complete at your schools in 2 or 3 weeks. So we just do all of this and we recorded it in one lesson. Then we know we have done that one powerful lesson that is everything. Then when you prepare for your exams, you don't need to study whatever. You just watch this lesson and you know it has everything. You guys know Kota very well. I think it's Bani Chow in English, for those of you who don't know that. So a quarter has got a bit of a potato, a Vienna, a Russian there, a quarter of a bread. It also has a tomato. What else? Oh, we also have acha. What else are we having in a? Oh, we also have a what is it? A polony. Yes, polony. We also have a slice of cheese there. I'm not sure if you guys know a quarter with a chicken feet, but you 2000s, you don't know a quarter with a chicken feet. Guys, as we had nice quarters during our time. Okay, so this is what I'm saying, guys. For you to taste each of this, you do not need to cook potatoes on a Sunday and then put a fry. Is it being fried? A Vienna there. Oh, we also have some eggs, and fry some eggs. Fry Vienna there. Whatever. No. You just do a quarter and you have a bit of those. You put in everything inside. Then this is that soft part of the bread. When you chow this thing, guys, you have tasted everything there. So it's more like you can take 20. No, let me not say 20, but let me say you can take 1 hour to study the whole chapter. Then you know you are done. You move to functions. You still take 1 or 2 hours to prepare. You move to financial maths. You still take 1 hour to prepare. So someone will waste their time and take an exam question paper and try to solve from question number 1, 1.1, 1.2, and whatever. Whereas in my case, what I would do, guys, is to study the question papers from 2009 up until 2012, just doing question 1 only. From there, I derive my own questions, of which I know that even if whatever a math problem it is, it might be having 2x squared, square root of 3, x squared less than, and it still has whatever over whatever. On this side, I still have whatever to the power. So I'll be having this math problem of this side. That side, something that you've never seen in your life, something that you've never seen in a question paper. For me, when I study, I no longer go back to those question papers. I just look at this and say, okay, for question 1, our question might have a square root. How do we deal with a square root? It might have an x squared. How do you deal with it? It might have an inequality sign. How do you it might have a power of that. Okay, it might have a fraction. It might have that. So in just 20 minutes, I'm done with question papers from 2008 up until 2012. Then I'm done with question paper. In question 1. Then I know I'm ready for tomorrow's test. I do the same for question number 2. From 2000 whatever up until that, I write all the strategies and summarize. I write all the tricky parts in all the question papers, then I summarize. Then for me, I say, okay, examiner may say, find this. They may say the common whatever. They may say whatever. Then I know what to expect and how to respond to whatever I'm expecting. Easy. Guys, did that help someone in any way? Can I hear I receive somewhere there? Did that help you guys? Hey, let me check. Oh, you guys are still there. Team Giddy, did you hear that? Grace, did you hear that? Okay, just in case if the message is still delivering, I'll just in the meantime continue. Okay, what are we now talking about, guys? So when we add the terms of a sequence together, we form a series. It's as easy as that. Cogsa the cogsa. We say when we add, what is to add? To add is to plus and plus and plus. So when we add terms of a sequence together, we actually form a series. Easy, guys. So it's more like when you just say term 1, the moment you see a plus, plus in term 2, and you see another plus in term 3, another plus in term 4, and so on and so on and so on and so on. Ladies and gentlemen, for the fact that we are adding terms of a sequence together, therefore we are forming a series. Very, very much important, ladies and gentlemen, over there. Most importantly, you need to be aware that in this case, we'll be talking about 2 types of series. The first one being arithmetic. It is therefore going to be a series, arithmetic series. I wish Lerato attended this lesson. I was going to ask her to say arithmetic. Yay! It's like me asking Toli to say but I'm sure she might attend tomorrow's lesson. I'll just make sure to remember to ask her to pronounce arithmetic. Hey, I'm telling you guys, you're going to have a very great time in hearing her saying arithmetic. Okay, so what are we having there, ladies and gentlemen? We are now talking about a series, our lazy friend. This lazy friend of ours, he said, when you add the terms of a sequence together, we generally have something of n over 2 into 2 A plus into N minus 1D close. You remember our lazy friend is good in deriving these formulas. They punished our friend to say add this 50,000 terms. So they gave him 50,000 terms, and it was 2, 4, 6, 8. Hey, you could notice that no. This is too much work. I know it's difficult and it's too much of a work for Toli to say, but to add all the terms up to 5,000 is too much. So our friend just worked out this general formula based on just 4 terms of a sequence. So because of his laziness, ladies and gentlemen, we were therefore able to have this formula as it's nothing else but the sum of nth terms. So that is for the sum, n for the nth term. Easy, 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 easy. You remember very well that A, it's actually T1 or term 1 or the first term. And again, N is just the number similarly to that one over there. D, ladies and gentlemen, this is the first CD. For someone who started with my lesson, they will know very well that when we talk about the first CD, it has to do with arithmetic sequence because this is where we have the first CD. But when it comes to quadratic, we have the second CD. And then with geometric sequence, we have the first common ratio. Very, very much important, ladies and gentlemen. Okay, so now let's try to talk a little bit more about I'm not sure if I'm going to have enough space over there. Geometric, what is it? Remember, we are talking about series now. So whatever that you say, we say in the end has to be series. I don't think I'm going to have enough space over there, ladies and gentlemen, but let's see. Okay, I'll just fast track it. So remember, guys, in case if we are dealing with a geometric series, you do know very well that we'll be talking more about the ratio. So even in the formula, you might have a guys, our lazy friend. Our lazy friend was punished and he ended up having Sn being equals to what is it? A into R to the power of n minus 1 over R minus 1. And he said, you can only use this formula if the ratio, ladies and gentlemen, it's actually greater than 1. And he noticed again that this formula, it can't work if R is less than 1. So that means if R is less than 1, you can't use this. Hey, what is R? R is the common ratio. Very, very much. Okay, so now this is the formula that you use when the ratio that you get when you say this divided by that, if it is a value which is less than 1, ladies and gentlemen, that means it could be 1 over 2, it could be 3 over maybe 4 or whatever. As long as when you convert it to a decimal, it is less than 1, then you know you use this formula. What does the formula say? The formula says A into, then you start with 1, it's R to the exponent n over 1 minus R. So for some time, it was a bit of a challenge for me to cram or remember which one do you use when R is what. But I noticed that you just want to have a positive number at the bottom there. And how do you have a positive number? That's if you say a bigger number minus 1. So can you see, if you have a bigger R, then you are going to have a positive denominator. And if r is less than 1, that is why for you to have a positive denominator, you must say 1 minus a smaller number. So that is how, for me, I was able to cram which formula do you use, because you are guided by the value of r. So that means it is very, very much important, ladies and gentlemen, that you understand how to determine r correctly, and then from there you are going to use the r value to determine which formula to use between those two over there. Okay, lastly, what is a? Easy, 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 easy. If you had your very nice breakfast with a boiled egg and a peanut butter, you know you call the first term A. Okay, what is R? Good people, R is the common ratio, the first CR. Okay, what is N? So that means always, 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 N is the number. Always, 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 N is the number. It doesn't matter on which formula of the sequences or series or whatever. In most cases, N is the number. Sn. What is Sn, ladies and gentlemen? I've just explained to say Sn is actually the sum of the nth term, or sum of the terms. Guys, that's all that I wanted us to talk in our family meeting. I'm not sure if you, my grandchilds, are having questions then. This is towards the end of our family meeting, ladies and gentlemen. But before I close, did you guys get value? I asked this question and I noticed you couldn't respond. But did you guys get value out of this lesson? Was it worth it to attend?
The lesson was
Was it dope? Let me see. Bonol, was it dope? Hey. Shravan, was the lesson dope that side?
the lesson was nice.
Oli, was it dope? The boy doing them things. Cogs are the cogs. Likeleli. Grace. Bonolo.
It was dope, sir.
The lesson was nice.
Okay, guys. This brings us to the end of our lesson for today, and I hope you did enjoy as much as I did. Just before we wrap up our lesson, ladies and gentlemen, let's check. So we did cover a series and we've looked at arithmetic and okay. So the other thing which is remaining, of which it's something that we might need to cover on our next lesson, it's that one of sigma notation and infinite geometric sequence. So just make sure that before you write your preparatory exams, we did discuss about sigma notation. And again, infinite geometric series. So can you see? You are now familiar with the word geometric series. You know series, it means you are just adding terms in a sequence. And then the geometric is that one of a common ratio. What you do not know is that word being infinite. You might know, yes, but let's assume that you do not know because I haven't explained to you. But once I do, I'm going to say you now know. So when we answer exam type of questions, I'll be knowing that I did discuss what we call infinite geometric sequence, same as sigma notation over there. Okay, ladies and gentlemen, thanks very much for joining. Have a good night and Bye. Cheers, 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 guys.